Hi and welcome, ladies and gentlemen. Today we're talking about insertion sort. Well, insertion sort is a basic algorithm for sorting data and it is array based. Well, the idea is that we always look from the back to the beginning of our array and find the position where we can insert our data element. So for example, if we have the last element and our element to insert is smaller than the last element, then we move the last element in the array one further to the right, and then we check with the next one until we find the right position to insert the element. And it is a stable algorithm and it has a runtime in worst and average case of n squared. And that is when the array that we want to sort is sorted in reversed order. Alright, so let's have a look at an example. Well, we have here our initial list, which is 75, 38, 42, 1 and 10. In our first run, our array is empty, so we just insert the first element, that is our 75. In our next run, we have the 75 in it already, and we have to compare now the 38 to the 75. And we figure that the 38 is smaller, so we move the 75 one further to the right in our resulting array. So we move that one further to the right, and then we are already at the first position, so we can insert our 38 there. And then in the next step, we have our 38 and 75, which are in our resulting array. And at first we compare now the 42 to the 75, and we figure the 42 is smaller, so we move the 75 one to the right. In the next step we compare the 42 to the 38, and we figure the 42 is greater than the 38, so we found our position where we have to insert it because the 42 is greater than 38 and it is smaller than 75, and we insert it there. Alright, then we go in our fourth run, we start with our array 38, 42 and 75 as our result, and now we want to insert the 1. So we compare the 1 to the 75 figure, 1 is smaller, move it 1 to the right. The same with the 42, the 1 is smaller than the 42, so we move it 1 to the right. And the same again with the 38, so we move this 38 1 to the right. And then we are at the beginning of our array, so we insert our 1 there. In the last step, we have our 1, 38, 42 and 75 already in our result. And these, as you can see, are sorted too. So now we have to insert our 10. So at first we compare the 10 to our 75, it is smaller, so we put the 75 one further to the right. The same with the 42, the 10 is smaller, so one further to the right. The 38 the same. And then we compare the 10 to the 1 and we figure the 1 is smaller, so we found our position where we can insert our 10, and that is between the 1 and the 38, and we end up with a sorted array. So let's implement that. Alright, for that I create a new file and I call that Insertionsort. .python, and for that I at first want to import numpy because we will use it a lot here, snp, and then I want an array length for our array where we generate soon some random numbers. I say here 10, then I want array min, or let's say rand min should be 1, and rand max equals to 100, and that just defines the range of numbers where we generate some random numbers. Then I want our array to be a random numpy array where we take nprandom.randint for random integers we have our low, that is rand min, we have our max, that is rand max, and we have our amount of numbers, and that is array length. Let's just print it for now here, our array. Alright, as next we need a result array where we are going to insert our data. And there I want to create our result as np, and here I say full because I want a full array, and that gets a shape, and that is just our array length because we just have a one-dimensional array, and it wants a fill value, and our fill value will be array min. Alright, so now we have our result filled. We print it quick here so we can see how that looks like. If I run it now, we see we created our random array here with random numbers, and we have our min value as our result currently. Okay, so now I go in and say for each I in our, and there we need to go through our array. Here array line, we have it already. Okay, and now we have to use a trick where we say our j equals to I, because we want to go from our I always to the front, and yeah, have a look which ones we have to swap. So there we go, while j is greater than 0, and for now I just write pass here. So, and then here afterwards I want to insert our element. So I go in and say our result j will be our array I. Alright, so good so far. And here we go in and say, as long as our j is greater than 0, now we have to check if our array I, so the actual element at I, is greater than the element at our j position. And here, as you see, if we are at 0, because I can be 0, we don't go in here, and then we say result 0 is equal to our array 0. So we insert there the first element. Alright, so now we have to check if our result j minus 1 is actually smaller than our array I. Then I want to break. Why? Because then we found the position where we want to insert our element I of our initial array. And otherwise, I want to say result j equals to result j minus 1. And that is simply the shift that we do where we move our array one further to the right. Alright, and when we are done with that, I want to print our result. And that should be our sorted array. So let's run it and hope that everything works fine. And here we still run into an infinity loop, and the problem is here that I don't increase our j. So here I say, or decrease, j minus equals 1, because we go from 1 to, or from, I to 0. Let's run it again. And as you see, our array is sorted here. And that looks perfectly fine. Let's try it again. We use random numbers, so that should secure that we work on good data, or that our algorithm works on different types of data, and that looks perfectly fine. Alright, ladies and gentlemen, thanks for watching this video. Give it a thumbs up if it helped you, and subscribe to the channel to always get informed whenever I'm uploading new videos. As always, you find the source code of this video in my GitHub repository. Link is down in the description. Well, tell me down in the comments what you think about the video. That's it for me. Have a great day. Bye.